Okay. Let's see if this all works. Yeah, okay, seems fine. Alright. Then let's get started. Alright, so the first thing we're gonna have to do is the automatic texture resizing for the render passes. So, just like here, we do need a no, we can go, sizing policy, match window size. On resize, so we need another class, which should be also another struct, which is something like, yeah, well, a description of what textures we need and whether they are eager or yeah, like how to create them, pretty much. So we need something like, yeah, I guess we need a resolution policy. Alright, we need the policy, then we need the width and height of the texture. And we need an attachment. I think, yeah, because it's a render target. So we also need a what are they called again? I think just texture attachment. And we need a texture pointer now that I think about it. Attachment, okay. This is texture descriptor. Nee, target descriptor rather. Yeah, okay. Okay. So this should be textures. So this is our render target, that's correct. We have our uniforms, that's also fine, and then we need like our which is a std vector of texture description. Or rather it's attachments now that I think about it. On resize we are gonna do or check the switch the description.policy. Then we also should create a new resolution policy. Exact. Case resolution policy exact. This falls through, and then we have resolution policy match window size, and we need another one which should be fractional. Okay. Now we need, first of all, we're gonna have to get the engine. Does the render pass have? No, it doesn't have an engine. Okay, so we can use the singleton. Destroy. Destroy description.texture, and then we do description.texture equals what we created. We look, here we go. This is what we're gonna need. Okay, and oh, we also have to get the levels and the internal format. Do we have something else we need to attach? No. Okay. So we need the texture internal format, and we also need what was the other thing? Levels, right? Size 10 levels. And then this one. Width is size.x, size.y, and description.levels. Color attachment sampleable, that's always the same. And then we need our internal format. Okay, now we do a log info. Well, now the issue is pretty much that we just have to, we connected the textures together down here. So we got our render graph, we add the pipelines, and up here we connect the textures, but whenever this window resizes we get a new texture pointer, we can't use this anymore. This isn't so simple. We pretty much need a proxy object that automatically reconnects whenever it's like needed to do so, right? So we have to associate more state with the render path than I actually hoped it would need, but I think there's no real way around it. Okay. This is kind of bad. Yeah, we also have to update the render target. target. I don't think we can update the attachment pointer after creating it, right? Oh god, this is really bad. Then I have to recreate the entire render target. Oh man. That really sucks. Okay, I think we're gonna do something different. I think we're gonna write our own working renderer. Because I just always keep hitting these roadblocks with Filament where I don't know how to properly implement the things that I'm thinking about, right? Because we need to pretty much just like auto update our render targets. But I can't really do that because in here I have to now recreate the entire render target. And like we're using this render target here like with the output to connect multiple render passes together. But this is a stateless operation, so we just connect the textures once and we're done. So if we resize it, then the textures get invalidated and we like can't do shit anymore. Okay, so I gotta go take a quick break. I'm gonna have to go to the toilet.
Slow down, I wanna make it last. You got me falling fast. No doubt, you're what I never had. Kerosene to a match. It's a force of nature I just can't deny. And you know there's only one thing on my mind. It's me and you, me and you. California to Bombay, let me get that body on me. Yeah, you, me and you. In a rickshaw or a Rari, doesn't matter, I look good on you.
Okay. So I spent some time thinking about it on the torrent, and I think I reached a rather good conclusion, if I say so myself. We're just gonna do the connections also in a eager or in a declarative approach, where we just say we want this, and the engine connects it whenever a connection is needed. It automatically does that for us. So this is gonna go into the protected thing again. Oh wait, what? This doesn't make sense. Okay, it's a builder, I say. Add material output. So what we're gonna do is we add a void connect, which just takes whoops. So we need, I think what we're gonna do is root pass minus connect. Oh, I need to set q functions to empty, and then we connect it to UI pass. No, we connect this to composite pass. Does it pass? pass, right? So we have the render target, which is a shared point, I think. So that's great. We can copy it over with a vector of tuples, where we just put the name of the sampler. So we need game pass. Then we need, since it's the input, we have to first we get our attachment point. So it's render pass attachment color 0 goes to game pass with an empty texture sampler, which is just linear filtering, I think. Okay, let me think about the semantics of this. Then this would look something like UI pass would look something like this. Yeah, here we can. I think this is kind of good. So we need a stitch shared pointer over render pass. Pretty much, what do we call it? It's the input, yeah. And then we need a vector of tuples, or layout. We can call this variable, and this is the attachment. This string, which is a uniform, and we have a texture sampler. And then we just take this whole thing, and now we do a stitch unordered map with a stitch. Okay, no, that doesn't really work, but can we put a shared pointer as the key of a stitch? I don't think we can. What we can do is we can make a linked list. So we just need the layout, well, the output layout. Output, I guess we can call it. Which does C++ have a built-in linked list in STL or not? It does. Alright, okay. So we need a stitch list with output layout, whatever, right? Yeah. So we need target layouts, maybe we call it. Yeah, we can refactor this later if I don't like it. So we need struct target layout, which just has the previously added this vector. So we need this. I think that's it, isn't it? Do we need more? So we need output layout dot push. And we can do place spec target layout, and layout is layout. Maybe that works. I don't know. That maybe call it maybe setup or something. If it's not initialized yet, we automatically initialize it with whatever size we have now. But then then the render pass also needs pretty much, it needs to know in which window it's running. I'm gonna have to think about this for a second.